So your device layout is built. You have all your labware defined along with the operations you want attached to them during a process operation. Specific zones have been created, making it easy for end users to load their labware. There's only one thing left to do: teaching the system. Welcome to part 3 of the Genera from Zero to Hero series. Interesting that this is the third part, and we have a special guest today to make our whole thing come together. We have Mr. Eric Padilla, who is at headquarters. He's going to be our hand model today to help us out with some teaching, and we're doing this all live with all of this moving plates around and showing you how you're actually going to teach the system. So this should be exciting. Igor, why don't you explain a little bit about what's going to happen today and then take it away from there.
Yeah, this is super exciting because this is our first live demonstration for one of our videos. So in this case, we have Eric at our office HQ, and we will be going through the entire teaching process from selecting your nodes to adding the teach paths, moving the arm, and then testing it out at the end. So let's get right to it. And as always, I'm going to share my screen.
Great camera views. Okay. I love it.
Yep. So we have our arm. And so in this video, we're going to be teaching the hotel and a nest in our OpenTrons Flex that we have at the office. And as always, we're at our scheduler view, which is our dashboard view. And in order to start the teaching process, we're going to go to our editor. And here, there's two ways we could get to our robotic arm teaching pendant. We could either right-click on the arm, click Teach, and click on the nest, and it'll take us right to our Teach pendant. Or what we could do from our layout is click on the robotic arm teaching, and it'll also take us here. So the first thing we want to do is we want to select our orientation. So Genera comes with a default of landscape and portrait, but you could add more orientations like reverse landscape and reverse portrait here in our settings. As you can see, our path orientations here. So in this case, we're going to be teaching this hotel in portrait. And as you can see, it comes default with a safe and an approach. So how I like to think about safes is that the arm is able to travel to all the safe positions for all the nodes that are taught in your system. So in this case, we have our hotel and then we have our OpenTrons. So we just want to make sure that it could go to each safe position without running into any instruments along the way. And what's special about teaching a hotel is we actually don't have to teach every single shelf of the hotel, which makes life a lot easier. What we do have to teach is 2 shelves. So we have to make sure we add 2 shelves. So I'm going to add shelf position 1, and I'm going to add the shelf position 13, which is the top one, because this is a 13 shelf hotel. And so after teaching, Genera will actually interpolate all your shelves depending on the teach positions of the top shelf and the bottom shelf in this case. And then another thing we're going to do is we are going to add one more approach. So this is all just set up. So the safe will be, where it's at right now, where it's folded in on itself, make sure that it can't hit any instruments. And what we're going to do to actually teach is click the teach button. And so what this teach button does is it'll save the X, Y, Z yaw pitch roll of the arm at its current position. And so to start teaching, what we're going to do is we are going to make sure we unfree all axis. Because when you unfree the axis, I'm going to actually move this down here. It'll allow us to send commands to the arm for movement. And we're going to, and as you can see, Eric is shaking the arm, so it cannot be moved in this state. And we are going to make sure we close the gripper to the position we want to put the plate in. So for portrait, I like to use a position of 75. So these are all in millimeters. And we're going to run this command. And as you can see, it'll close in the grippers will close to that value. And then I'm going to need Eric to put the teach plate or teach jig inside the grippers. And Jeff, do you want to explain the importance of this teach jig here and why we use it for teaching?
Certainly. This gives you the a standard height and connectivity into the grippers for the teach jig. So when you teach all positions, it's at the same spot for every one of those. Now you could also make changes for specific pieces of labware if need be, because different labware is not going to be the same height as the teach jig. So you may have to adjust that, which is in the labware teachings table on this screen you see before you. But the teach jig provides a quick, rapid move in, move out to positions to teach upon those nests.
Yeah, so it's very useful to have when teaching the robot.
Yes,
you can
very much
use
so.
your microplate that you use for your system, but as Jeff said, if any variability in your teaching could cause errors to happen down the line. So after we put the teach plate inside the grippers, what we're going to do is we're going to free all axis except for the grippers, because we don't want those grippers to move, but we want to be able to move the robot. We're going to run this command. And so how I like to teach, and as you can see, Eric moving the robot, so now it's free. How I like to teach is I like to teach the nest first and then work backwards from there. And as you could see in our bottom left here is our approach shelf. So this is the shelf that we're going to use to teach the robot. And we could choose a different shelf, but in this case, I'm going to use shelf 1. And so we're going to start the teaching at shelf 1. So as you can see, Eric is currently putting the plate inside of the shelf 1 of the hotel. And after he's done with that, we are going to teach shelf 1. Click the teach, and there we go. And next, we're going to teach our second approach. So we're going to do the shelf 13 last. So with the approach right before a nest or a shelf, what I like to do is I'm just going to Control C and Control V, copy and paste, the same exact values, but the only thing I'm going to change is the Z value. So I'm going to change this to, let's say, 35 for testing. And I'm going to move to this position to make sure that it has enough clearance so that if I move it straight back, it could move out of the hotel. And so what I'm going to do is I'm going to unfree all axis, because I need to make sure to unfree if I want to do any movement commands. And then I'm going to move to this position. And then Eric will let me know whether it is good enough to, or whether there's enough clearance for it to pull out. So there we go. Thumbs up from Eric. And then another thing about a hotel is that all it needs to do right now is just move straight back in the y-axis. So I'm going to do another copy, another paste. And, well, let me just double check that this is, actually, no, we're going to move it back. I think that's better. So I'm going to free all axis.
Just do a jog.
Yeah. Well, I'm going to just have Eric move it back. I think that's easier in this scenario. So if you could just move it back to where it's in front of the hotel. There we go. And then I'm going to click the teach button here. And then now we could see, okay, I think I misspoken a little bit. So it's actually the x-axis. So you could see that the main difference between the second approach and the first approach is just a large x-axis difference. And then what we could also do to make sure that it is only the x-axis that's moving back, we could just copy and paste these values. And also the yaw. We could. So now we know that it's just because the arm and the hotel are parallel to each other, so it should just be able to go straight into that shelf.
Yeah, I think it's important to put some context to this. So what Igor has just done is if you look at the plate as he originally taught, which was the nest, everything was inside. Then he copy and pasted everything in the nest position and changed the Z, which only brought it straight up. So it was hovering there. And that was now the new position for the first approach, approach 2. Then the next one was a straight out move, where Eric brought that, and that was approach number 1. So he wanted to keep everything straight in a straight line as you look at it coming towards you. That's what he was achieving with those particular point values.
Exactly. So what I'm going to do, just to check it out, just to make sure that it looks good, I'm going to unfree all axis. And then I'm going to move to the new approach 1. So there we go. So now it's all it's going to do when going to approach 2 is it should just move straight in. I'm going to move the robot arm. And as we can see, it actually crashed. So as we can see, it said the position tracking error exceeded the configured soft limit. So what's nice about these robot arms is that they're collaborative. So if there's any crashes that occur during your teaching, and trust me, there will be crashes because, ideally, things happen, exactly. So how do we recover from an error due to crashing of the robot? So all we have to do is click OK on this error, click Clear Error, and now we're good to go to try again. So we're going to move back to our approach 1. Going to move. There we go. And what we're going to change is the move type. And Jeff, do you want to explain what the move type does?
Yeah, certainly. Move type 0 or 1. 0 is a joint move, so it'll use every joint that it can. And a 1 is a linear move, so it's going to be in a straight motion, in or out, left or right, whatever is decided upon or needed to do there. So in the case of how he taught those originally, we want it to come straight out, or in this case, between the towers, the red towers there between the stanchions, and go straight into the above nest position, which would be approach number 2. So in order to do that, we can't just come out any old direction. We have to go straight in and straight back out. And that's what the 1.0 move type actually does for you.
Exactly. And I just got word from Eric that the plate isn't fully centered, so the hotel isn't fully parallel with the robot arm. So what I'm going to do is I'm going to free all axis. And then I'm going to have Eric move the plate a little bit so that it'll actually enter into the hotel. And then we're going to keep these teach positions because they're not parallel, so we can't really rely on just the x-axis going back. There we go. Eric gave me the thumbs up. So we're going to teach this position. And now we're going to unfree the axis again. And then we're going to test this out with the move type of 1. And as we should see, that it should just go straight in. Perfect.
Yes.
And then
Success.
We could also go down to shelf 1.
And that was the linear move. With that move type change to a 1.0, that was that straight in linear move, not based on all joints to make the move. Just go straight in and straight back out. That's important to keep in mind, especially when you have tight positions, such as these hotels that you're trying to get out of.
And another note is the move type doesn't really matter for the shelf 1 because the only thing that's changing is the z-axis, and the z-axis only moves linearly. So we don't have to worry about the move type for the shelf. So last thing we have to do is teach shelf 13. So I'm going to free all axis. And then Eric will move the plate onto the nest of shelf 13.
Now, what Igor is going to do here is the same iterative process that he did for shelf number 1. Teach the nest, teach an above, and teach a retract in that case. So it goes the same way. So you avoid everything between 2 and 12 because of the it gets iterated through on how it's going to work.
Okay, I got the thumbs up from Eric. So what we're going to do is click teach, and we are done with teaching the hotel. And so I'm going to have Eric move it back to a safe position. And the last thing we have to do before we can actually test our teaching positions is change our gripper open and gripper close values down here, because it always defaults to 130 and 120, which are good values for landscape position. Landscape, yep. But we are picking up the plate in portrait. So I'm going to change this to 90 and 75. And we could change these values later on, but just for testing purposes, we're going to try those out. I'm going to save everything. And now we're going to use our test path to test our positions. So we made a video on this previously, but we can actually walk through it live in this case. So do you want to give a little background on the test path?
Certainly. Yeah. Yes. Test teach path, which was our last released video, will take you through physical movements as the video had demonstrated of nest positions around the deck or hotels in this case. And it actually steps through. Previously, you saw Igor clicking the move to, move to, move to, which was very clickish, very, click here to move again and again and again. With the test teach path dialog, this allows you to step through every point on the table there from safe 1, approach 2. In this case, he's going to use shelf 13, I think, or shelf 1, depending on what he wants to do. But he has the shelf number up there that he can select. So it will step through each of those points in the table, and you can check those for every point in the actual hotel.
Yeah, so in this case, I'm going to test shelf 1 first, because that's our approach shelf. So we're going to click next. So it's going to, so if you ever get this error, the request in motion requires standard. I don't think I could expand this, so I can't really see the full error, but usually it's because I did not unfree all axis. So we just have to make sure to unfree all axis before we do any movement commands. And now I should be able to step through this. So if I click next, there we go. So there's my safe. I could go to my approach. There we go. Go to my next approach, which should just slide straight in, and then go down to my shelf nest. And then can I get a thumbs up from Eric that it looks good? Perfect. And then to go backwards, so since I know I could step through it forwards, actually, let me step through it backwards just to double check. So we're going to go backwards now.
Came up.
There we
came out.
Back. And now it's going to go up. And now to do this more fluidly, just to stress test this, I can now click the move, and it's going to do the full movement smoothly without having me to click anything. And then I could also go backwards.
So this allows you to iterate. This allows you to iterate pretty quickly through a hotel or other nest positions on the system itself without having to click so many times on the move to.
And exactly. So I could choose another shelf, let's say shelf 6, just pick one at random. I could step through this first just to make sure that it's good to go. So now it's going to change the approach, the 2 approaches and the shelf position. So it's going to interpolate those values based off of the Z value. And so you can see it's now going to shelf 6 and go down. And then I'm going to go backwards. And it looks good. And then I can now move just to confirm that it's able to do this in one smooth motion. And then now I could test out the top. Now I could do 13. I could just go straight into the move. And we can see how that looks like. Nice. So now we have the hotel top.
Excellent.
Excellent. So then the next nest I'm going to teach is the OpenTrons nest. So to go there, I click on my layout-hotel tab here. And then as we can see that the hotel 1 changed color because now it has it taught. So that's how you could tell in your workspace which nests have not been taught and which nests have, or nodes. So I'm going to click on my nest C1 because that's the nest that we're going to teach on the OpenTrons. We're going to click OK, and we're going to go through the same process. So we're going to click on the orientation, which is portrait. And as you can see, this is slightly different than the hotel. So we have our safe, one approach, and a nest. So obviously the nest doesn't have multiple shelves, it just has one nest. So we just need to teach that. And then we could add approaches or safes as need be. So I'm going to keep the safe the same. So I'm just going to teach where it is right now.
And we have a better camera angle on this too, don't we?
Yes, we do actually. Thank you for reminding me. We have a top-down view. So we could see the nest, which is right here, of the C1 position of the OpenTrons. So same thing, we're going to go from the nest and we're going to work backwards from there, adding approaches as need be. We're going to free all axis, run the command, and then Eric is going to place the plate inside of the OpenTrons nest. And then once he gives
He's so good at that.
I know. What a nice hand model.
Hopefully he'll expense the manicure that he got.
I know. Okay, we got thumbs up. So we could click on the teach button. And then we're going to change this approach. I'm going to copy this, paste this here, and we're going to change the Z value. I'm going to actually increase this quite a bit because I want to make sure that it clears those thermal cyclers in the reader there. So we're going to just increase it to like 200. And I'm going to unfree the axis. And I'm going to move to that position.
Yeah, I think it's important for viewers to understand how quickly they can capture a teach point and paste it like you just demonstrated, Igor, because you're right. You're only changing the Z value. So you just want the robot to move straight up. There is no move type change here. It's just changing Z values and everything being the same. Think of it as above the nest, and then I'm just going down, up and down. That's it. So that's important that as the viewers watch this, that you can copy other teach points if need be.
And it minimizes the amount of work you have to do.
Correct.
So you don't have to, unfree the axis, move the plate up, teach it, and it ensures that you go just straight up and down. So there's no other variations in the other positions.
And if you had to do this by yourself, that saves a lot of time too.
It saves a lot of steps as well.
Nope. Not everybody has an Eric hand model.
Yes, exactly. So we're going to test it. So we could add another approach, right, to make sure that it could go back to the safe position, but we're just going to test it out, see what happens. See what orientation or what path it goes to go back to the safe position. And then I want to get a thumbs up from Eric just to make sure that it's clearing the thermal cyclers so So I'm assuming that's a thumbs up. So
Thumb sideways, I think.
yeah. So what we're going to do is we're just going to go straight to the move to, save position. And so if it's good, then we don't really have to worry about it. But as we could see, it hit the thermocycler. So we need to adjust that position. Oh, we need to add another approach to make sure that it doesn't hit it. So we're going to click OK, clear error. So recovering from errors is just as easy as clearing the error. And we're good to go to add another approach. And then we're going to move this up because we want this to happen before the second approach. And I want Eric now to move the arm backwards so that it could avoid the thermocycler.
Yeah, this is the same sort of scenario that we would have seen in the hotel, which we did, where it hit the side of the hotel to get in there. There are things around that nest position, that teach point, that you have to get around, and you can't necessarily come in from the sides or low in this case. So you do have to come out a little bit and make a way in, straight in or out. Depends.
So that's why you could add as many approaches as you want or as you need for your
Exactly.
teach position. So we're going to try these two now. So it should be at where the first approach is where it's at right now. So I'm going to unfree the axis. And then also adjusted the Z value so that it could hover above the thermocycler. And if we move to it, it should go above the nest, hopefully without hitting the thermocycler. Perfect. And then we could go down into the nest.
Yeah, and it's important to note that the approach that Igor took here, pun intended, was not to change a move type, but to swing the entire arm in above all the devices surrounding that nest position, which is another option. He could have just came up a little bit and moved straight back out like a hotel if he wanted to avoid all that, but he brought it up high enough that it clears all the other devices around that nest position, which is another option.
And to fully test this out, we're going to move it back to its safe position, and we're going to go to our test path, and we're going to move. And now we can see it's going to go above and drop it down into the nest, and we could go backwards from there as well. And then one thing that I need to do is adjust the gripper open and gripper close, similar to the hotel. We can go 90 and 75. And one thing to note with the test path is you could also open and close the grippers here. So if you want to test it with a real plate, you could open the grippers, and it'll open it to these values, and you could close it. And so you could test out the values for the open grippers and the closed grippers in the test path as well.
Yeah, after it sets down, you could open it and then come back out, and it won't have a plate in its grippers anymore.
So to fully test this, I'm going to close this. I'm going to save our values. So now we're done teaching our nest and our hotels, and we could do further testing, right? We could test it with microplates. We could test it with any other labware we're going to have with this. And another note is with our labware teachings. So Jeff, you want to give a little background on what our labware teaching does?
Yeah, certainly. This allows you to make tiny adjustments to teach positions, not at the position itself, but using the labware. So when it's called, that will make a slight adjustment on where the actual arm is going to grab the plate. A classic example is like an Eppendorf PCR plate, which is a very thin PCR plate. And based on the teach jig, it is much shorter than the teach jig. So if you had that in this list here, remember defined in the projects, then you could change the Z value to something that is a little lower. So when the robot comes in, it's not at the standard teach jig. It will come down and then be able to grab that plate and move away. The robot arm is going to look at this teach table every time it grabs that piece of labware and say, hey, in this case, if it was -4 millimeters lower than what the normal teach position is, it will grab that plate at that particular location for that nest.
Yeah, and another point is also the labware height that you could set on the right here with the properties.
Yes, correct. And that's used for sort of a first in, last out stacking where you have plates coming in and on top of each other. The robot needs to understand the thickness of one and then the thickness of two. So when it stacks these plates on top, it knows how much higher it needs to travel as it continues to stack plates in a stacking type of operation.
And also it works with lids. So this is where you define
Yes.
the Z. So if you click on properties, we could select which coordinate I want to. So usually if it's stacking, it's Z. So you could define the Z height value or for the lids. So make sure that the lids stack on top of the plate correctly. And the stack height, as Jeff mentioned, is for stackers.
Yeah, and most of the time, whether it's in the labware offsets or the labware properties, it's going to be the Z that you're going to use most often. It's not very often, if ever, that we use an X or a Y value for those plates.
Mm-hmm. So now that we have our teaching finished, so to ensure, so another way we could check to make sure that our teach positions are correct is if we go to our scheduler view, as I mentioned, it's our dashboard view, and we could add a plate to the first shelf of the hotel. So I'm just going to add I need to associate this with a project with labware. Just double check that this one, there we go. So we're just going to put a microplate 96. And then if Eric, you could put a plate on the shelf 1 of the hotel.
The big test.
Yep, this
Drum
is the
roll,
big test.
please. Thumbs
So,
up, thumbs sideways.
so what we're going to do is if you right click, so you can right click on the plate and we can move it within the workspace. So as you can see, I could add plates in our workspace here, right? We could add whichever plate here. And if we want to like fill a hotel, for example, we could right click on the hotel and we could choose which shelves to populate with which labware. And if we want to pre-populate with barcodes, we can, and operational statuses or labware properties. And so if I was to right click, move in workspace, it'll move it to whichever node I click on. But as we can see, it's not actually going to move it physically. It's just moving it virtually. So to actually move it physically, we're going to right click on the arm and click move labware. And so I have to select the labware to move. So I'm going to select my plate, which is in shelf 1 of the hotel. And we want to move it to nest C1 of our Opentrons. And then it's going to give me a warning saying the robot arm will move, ensure path is clear. And so path is clear, and we're going to click OK. And we could see that it's actually going to move. Oh, I forgot that the teach plate was still there, but that's okay. And as you can see, it picked up the plate, and it's going to drop it off in the Opentrons. So as you can see, it wasn't the perfect drop off, but that's the general idea for teaching. And so we can actually go backwards. So Eric, if you could put the plate in the Opentrons nest. So this is where we can do some refinement, go back into our teach pendant, change around how the nest looks. I could either change it physically with the arm and clicking teach again, or I could change the values of the teach positions. And we're going to see if it'll work the other way. So we're going to click on nest 1, or we're going to click on our plate on nest 1, and let's move to shelf 5. And let me see if the other camera is better for this. There we go. And we click
Now,
OK.
yeah, I think it's important to reiterate what Igor is doing here. He did not have to write a process for this at all. He's using the actual scheduler view and the robot icon to move labware around the deck. So this is a teach test from a specific location to a destination, which is pretty cool. So you don't have to write a process to do this.
Yeah, and I could I could easily test out my positions, and then I could iterate from there. So using a combination of the test path and moving your labware in your workspace, you could ensure that all positions of your system is taught correctly. Because if you do it once correctly, you never have to really go into the teach pendant again unless one of the instruments move, or if you have to remove the arm for whatever reason, have to make adjustments after putting it back on. But outside of those scenarios, once you've taught it correctly once, you really don't have to teach it again afterwards.
Right. And even if a crash shows, that it will know where its position is, and once it's reset, it will go to that particular position. All right. So, Igor, is that everything that you wanted to show today?
Yes, that is everything for part 3.
That was fantastic. Eric, thank you so much. Thumbs up? Where is it? Where is it? We're waiting. Oh, no thumbs up today.
There we go.
There it is. There it is. All right. We appreciate Eric's help on this part 3 of Genera from Zero to Hero. We hope you enjoyed it and look forward to seeing you on the next one.